In this video, I want to take a look at interpreting the standard deviation. There are two main rules or methods for interpreting a standard deviation, and we want to go through both of them and then take a look at some examples. The first is called Chebyshev's theorem, and Chebyshev's theorem is a useful mathematical theorem, and it's useful for us because it works for any shaped distribution. Any data that you're working with can be interpreted using Chebyshev, and so it's got its usefulness. The second rule is called the empirical rule. While not a theorem, it is going to give us better numbers than Chebyshev, as we're going to find out. The downside of the empirical rule is that it only works for mound-shaped symmetric data. So we need that nice symmetric distribution that we saw, that we get fairly frequently when we're working with numerical information. If we have that perfect symmetry or pretty close to symmetric distribution, then empirical rule is the one we're going to work with, otherwise Chebyshev. So let's go ahead and take a look at Chebyshev to start and go from there. All right, now the picture I've drawn down here is the any distribution picture. And what I mean by that is the empirical rule works for symmetric distributions. So when we think about using Chebyshev's theorem, we're going to be working with other distributions. Now, you can see I've kind of drawn something that's decidedly not symmetric, and that's what I want you to think about when working with Chebyshev. Somewhere in the middle of all this mess is the population mean mu. And then what you can see I've done, and I haven't done it all that accurately, but what I've attempted to do is move 1, 2, 3 standard deviations. Each line, when you go from mu to this next line over here, that's a movement of 1 standard deviation. You can see the symbols that I've used in this picture are population symbols, mu and sigma. Remember, mu is the population mean. This is 1 standard deviation above the mean. This is 2 standard deviations above the mean. That's a sigma, even though it's an ugly sigma. This is 3 standard deviations above the mean. And I've done the same thing in the other direction. 1, 2, 3 standard deviations below the mean. The reason I'm doing this is because the rules, the way that we interpret the standard deviations, the rules that we look at give us 3 statements. And what I want to do is get my pen out here. What I want to tell you is that this is 1 standard deviation below the mean, this is 1 standard deviation above the mean. This first rule here, Chebyshev says that between 1 standard deviation above and below the mean, there's at least 0% of the data. Now, some of you are thinking about that, saying, that doesn't help. You're right. One of the things that we're going to see with Chebyshev, there's 2 nice things about Chebyshev. First is it works for any distribution. You cannot come up with a data set where Chebyshev does not work. The second thing we like about Chebyshev is it gives us conservative values. There's at least 0% of the data in this interval. There's probably more. Again, that doesn't help us all that much. We don't use Chebyshev for the 1 standard deviation interval too much. However, look what happens. When we go to the 2 standard deviation interval, when we go to 2 standard deviations above and below, there's at least, if I kind of shade in this region here, there's at least 75% of my data in here. And Chebyshev, of course, would say probably more. It's probably 80%. It's probably in the 80%, maybe mid-80s. So a good chunk, a fairly large chunk of our data falls within 2 standard deviations. And then we go to the third rule, or the third part of the theorem. At least, and in reality, the theorem says at least 8/9, but we typically think of that as at least 89% of the data set falls within 3 standard deviations of the mean. And again, I'm circling or putting a box around at least 89% because it's probably more. Okay, and that's a phrase that you always want to think about when you're thinking about Chebyshev. Probably more. And so the question that we're going to end up with here when we interpret a standard deviation, the measure of center, we looked at mean, median, and mode. Those measures tried to show us where the center or the middle of the distribution was. The interpretation of the standard deviation, it gives us a feel for the shape, the variation of the distribution. Really the question we want to answer is, where does most of the data fall? And most gets back to a measure of percentage. What do you consider most? Is 10% most? Nah, probably everyone would say no. Is 51% most? Some people are going to say, well, that's more than half, so that's my definition of most. And I'm going to try to back you off of that and say, no, our definition of most goes back to our discussion of reliability. We're going to say that most this semester is going to be 95%, really 90 to 99% is what we want to think about. Where our reliabilities are going to fall this semester, that's what we're going to use as most. And the magic number of most is going to be 95%. So as I think, say between 90 and 99% is at least zero, most. And you guys should all be saying, no, that's not most. Is at least 75% most? And remember, it's probably more than that. But even if it's probably more than 75%, it's probably not in the 90s. And so where do we get most of our data? Or where do we say most of our data falls? Using Chebyshev, even though it says 89%, some of you are saying, well, that's less than 90. Yeah, but it's probably more than that. You got to have a really strange distribution to only get 89% between 3 standard deviations and a mean. So we're going to say that most of the data falls within 3 standard deviations of the mean. And that's what we get out of Chebyshev's theorem. Now, that's one of the 2 rules that we're going to use. The second rule is called the empirical rule. And you can see bouncing into place here is a nice symmetric mound-shaped distribution. And you can see in this picture I've changed the symbols that I've used, and I've drawn in sample values, x bar, s. But I've done basically the same thing. Taken the x bar value, the mean, and then I've added 1, 2, 3 standard deviations in both directions. And so a similar picture to what we saw with Chebyshev. Now, let me give you a feel for why we use the empirical rule and why it's important and why it helps. And I'll try to take it outside of statistics, and maybe it'll help you see. I think one of the easiest jobs in the world is being a weather forecaster in the state of Florida. Think about that for a minute. Say we're working on May 15th. What's the weather forecast in Tampa on May 15th? Well, there's a pretty good chance, seeing how it's May, it's summertime here in Tampa. There's a pretty good chance that the afternoon high temperature will be about 90 degrees, with a chance of rain, scattered afternoon thunderstorms, of about 30 to 40%. Let's say 35%. Okay, now go to June 15th. Go to July 15th. Go to August 15th. What's the weather forecast look like in Tampa on August 15th of next year? Isn't it the same? A high of about 91. I think they change a degree from 90 to 91 to 92 occasionally just to make it look like they're doing something. And the chance of rain is probably 30, 35, 40%. It doesn't change that much. It's pretty consistent from one day to the next, pretty much from May through at least the beginning of September. All right, now imagine this summer you're sitting in class on campus, and I'm up front and I ask you, hey, what's the chance, what's the weather forecast today? Because it's the summer, you say, it's 30% chance of rain. Now, imagine the door opens up and someone walks into the classroom and they're just soaking wet. And then we're sitting there for a little while longer, and all of a sudden the lights flicker on and off as you hear some thunder in the background. Now, given what just you saw and what you heard, what you experienced, what's the chance you think it's raining right now in Tampa? At that particular moment, what do you think the chance of it raining is? Wouldn't you say it's higher? I would. If someone comes walking in soaking wet from head to toe, if we see the lights flickering on and we hear the thunder, of course we would. Because we have additional information. Not only do we have the kind of standard everyday forecast for Tampa, we now have some additional information that says, hey, here's some better information that you can use, which gives us a little bit better estimates. And that's kind of the idea I want to think about here. We have this Chebyshev, which we know works for every distribution, at least 0%, at least 75, at least 89%. But now we're working with the empirical rule. We also know that the only time we're going to be working with this rule is if we know the shape, if the shape is mound-shaped and symmetric. And so when we're working with a mound-shaped and symmetric distribution, that's the additional information that we have, that we know, that allows for better estimates. And you can see them coming into place right here on the right. Approximately 68% of the data fall within 1 standard deviation of the mean. Approximately 95% fall within 2 standard deviations. Chebyshev said at least 0 fell in here. The empirical rule says 68% approximately. Could be a little higher, could be a little lower. That's one of the drawbacks to the empirical rule. Chebyshev said at least, so we knew it was probably more than that. Here, it could be a little higher, could be a little lower. When we go out to 2 standard deviations, approximately 95%. Isn't that our most? That's going to get the official most here. Most of the data, when we're working with the empirical rule, we're going to be able to say falls within 2 standard deviations of the mean. We had to say 3 standard deviations when we were using Chebyshev, but with the empirical rule we can bump it into 2. And then approximately all or 100% of the data fall within 3 standard deviations of the mean. 2 different rules that help us interpret the standard deviation. And you can see that when we say we're interpreting the standard deviation, really the interpretation of the standard deviation has to be using the mean as well. Most of the data fall within 2 when you're using the empirical rule, or 3 when you're using Chebyshev standard deviations of the mean. How do you know whether to use Chebyshev or the empirical rule? Check your shape. Is it a mound-shaped symmetric distribution? If so, go with the empirical rule. If not, we're forced to use Chebyshev. And so these are our 2 rules that we will use to interpret a standard deviation. Now, how we use those rules, I'm going to take a look at an example and kind of go through a thought process. And I've talked about in class how a lot of the things we've talked about up to this point in time have been pretty straightforward. The definitions from the first chapter, the graphs that we looked at, bar graphs, pie charts, stem and leaf displays, not real challenging. The measures of center idea. Some of the things we've talked about haven't been real challenging. This next example is where I can start to challenge you a little bit. And so let me go to the next page. And typically what I'm going to do with this type of work, like I'm going to do with definitional type stuff, I'm going to give you words, I'm going to give you stories, and ask you to work problems in the context of a story. And so let's say I've collected some data from students, which I've collected in the past. Textbook costs. How much do your textbooks cost this semester at USF? And I stopped asking this question many years ago because the numbers started getting too big and students started getting a little upset with it. Like $400, $500, a lot of money. And then they start looking at my textbook and they're saying, hey, you're a big reason it's that high. And so now I ask you your ages and your heights, whether you have a tattoo or not. Kinder, gentler variables. Anyway, if I ask you your book cost, let's make the math easy. Textbook costs of USF students average $400 a semester, and a standard deviation of 75. And so I'm just setting up what we see in our data sets. Now, this problem can be solved if we think of it in terms of a population. It can be solved if we think of it in terms of a sample. That really doesn't matter. The way that we're going to approach this is the same. What I'm going to do now is ask you questions. Given that the mean is 400, the standard deviation is 75, what proportion of the textbook cost do you think fall between 250 and 550? These are Chebyshev empirical rule problems, interpreting standard deviation problems. You'll see how we do it in a second. The second question I'm going to ask, what proportion of textbook costs exceed $550? And then finally, what proportion of textbook costs are between $325 and $625? Now, I may have mentioned this in class earlier, but it's worth mentioning again because this is a good example. When I'm writing exam questions, when I'm trying to come up with ways of writing questions that are going to test you, I try to come up with a series of questions, a fair number of your questions on the exam that are what I call easier, basic, or what I'll call C-level questions. If you're going to get a C in the class, you should get that question right. And in this particular example, there's your C-level question. Now, you may not view it as a C-level question yet, but when we solve it here in just a second, you're going to see that it's a pretty straightforward question. If you understand interpreting the standard deviation, Chebyshev, the empirical rule, you'll understand how to get the answer to question A. Now, a little bit more challenging, not a lot, but a little bit, is the second question. Because Chebyshev and the empirical rule don't specifically answer this question. They will answer question A, as you're going to see, but question B here, you have to put a little bit more thought into it. And then question C is a little bit more thought even still. And so that's how I'm going to try to test you this semester. Do you have the basics down? Good for you. You'll get a C in the class. Do you know a little bit more than the basics? Can you do a little bit more difficult problem? You guys are headed for the B's. And can you do the most difficult problems? In which case you're headed for the A's. And so let's see how you do and see if that makes a whole lot of sense in this particular problem. So, what proportion of the textbook costs are between $250 and $550? Now, you should notice that there are these 2 rules, Chebyshev and the empirical rule. And so if there's going to be 2 rules, there's probably also going to be 2 different ways of solving them. And so what I'm going to do here is solve these questions both using Chebyshev and the empirical rule. And so here we got Chebyshev floating into play here. And I want to solve this problem, and in order to do it, I'm going to go get my pen. So let's solve it first using Chebyshev. And when I'm using Chebyshev, I need a non-symmetric mound-shaped distribution. So I've just copied and pasted the same picture I used earlier, and you can see we have mu minus 3 sigma, mu minus all the different things. Now, in this problem, we know the value of mu is 400. If we go one standard deviation above the mean, we know, that one standard deviation above is 475. We know 2 standard deviations above is 550, and we know 3 standard deviations above, and yes, you can see that I have trouble when I'm using the mouse to do this, and I probably should use my tablet. Let's see if I have any better luck with the tablet. Let's come over here with the tablet now. When I go in this direction, yeah, I'm not doing any better here. 325, back to the mouse. That's 1 standard deviation below the mean. This is 250. We're just going to stick to the mouse and get some ugly numbers. And this is 175. All I'm doing here is plugging in the value of mu and sigma. And really what you're going to have to figure out is, where does this guy fall? Where does this guy fall? Well, here we go. 2 standard deviations below, where's 550? 2 standard deviations above. Well, you just found out about Chebyshev's theorem, what, 10, 15 minutes ago? What's it say? Go look back. These are numbers you're going to need to remember for me. At least 75% of the data fall within 2 standard deviations of the mean. What you'll need to see is that this question sets itself up nicely using Chebyshev. We identify the 250 as 2 standard deviations below the mean. The 550 is 2 standard deviations above. What percentage fall between there? Well, Chebyshev tells me exactly what to expect. Well, not exactly. At least 75%. Probably more. So that's how we solve this problem using Chebyshev. When we go and think about it in terms of working with the empirical rule, so I'll say EMP here. We're still working with 2 standard deviations above and below the mean. Again, I've written this in terms of sample information, X bar and S. But tell me what percentage of the observations fall within. And again, this is 2 standard deviations below. This is 2 standard deviations above. You're doing the same thing. You're just using a different rule. And in this case, when we go to 2 standard deviations above and below, the empirical rule tells us approximately 95% fall between 250 and 550. Now, how do you handle this on the exam? How do you know? How do you know if you're using Chebyshev in the empirical rule? Well, I have to give you some information to determine whether to use Chebyshev in the empirical rule. And so you got to look for some clues. Now, there's a couple ways I can do it. One way is I could give you a picture of the data. I could say, here's what the data looks like, and you can judge for yourself whether it's mound-shaped and symmetric or not, whether the empirical rule can be used. Another way I can do it, and when you look at the practice exam, you can see that I do this occasionally. I'll give you some pointers. I'll say something clever like, assuming the distribution is mound-shaped and symmetric. Well, that should be a clue. If you miss that clue, there's something wrong with you, right? If it's mound-shaped and symmetric, you should be using the empirical rule. Now, I could give you the clue, assuming it's not mound-shaped and symmetric, which would indicate use Chebyshev. But typically, I will say something clever like, and see if you catch the subtlety here, assuming nothing's known about the shape of the distribution. Assuming nothing's known about the shape of the distribution is a slap in your face saying, use Chebyshev. And so you need to be able to come up with the correct rule to use, and then obviously be able to use it correctly. So hopefully that's a straightforward process. We'll see. For the purpose of going through this video here today and showing you how to work with the empirical rule and Chebyshev, I want to work with both, so I'm not giving you those specific situations. Now let me go to question B. And remember what question B looked like? What proportion of the textbook costs exceeded 550? So again, let's go with Chebyshev. And let me get my pen. I'm not a big fan of the pen turning off here, but what are you going to do? Remember, this is 250. And we came down here in the last problem. We said this is 550. Let's make that a 5. Okay. We just said, using Chebyshev, that at least 75% of the data fall out here. So if you have at least 75% in here, what's out here? Well, if there's at least 75% in here, what you have outside is at most 25%. Now, hopefully that makes sense. If you have at least 75% on the inside, you have at most 25% on the outside. And that's how we're going to work with Chebyshev. Now, I'm going to come back to this in a second. I may lose my annotations. We'll see. Let's go here. What proportion of the text costs exceed 550? Let's look at this problem again, but let's look at it using the empirical rule. And using the empirical rule, again, we have 250, and here we have 550, and we know that this is approximately 95%. And so if you have 95% in here, what falls outside? Well, if there's a total of 100% under the curve, if 95% fall inside, we want to know what falls out here. This is what I asked you about, right? I'm trying to color it in. I'm doing a pretty crappy job here, but yeah, we're getting there. We want to know out here beyond 550. Well, if you have 5% on the outside, what's this part over here? Well, the 5% factors into it. But what do we do with that 5%? We split it in half, because we got another half of it over on this side, on the left-hand side. And so the answer here is approximately 2.5%. And that's how we use the empirical rule. We use what we know, the 95%, to find out what we're asked to find. Now, I'm going to try to go back, see what happens here. Oh, that's good. Annotations are still there. Good, they're still here. Didn't know if I would lose them or not, my red marks. Now, let's think about this question in terms of Chebyshev. Assuming nothing's known about the shape of the distribution, what proportion of the textbook costs exceed 550? Well, we identify there's at least 75% on the inside. We've said that outside of 250 and 550, there's at most 25%, but really, and let me get my pen back, and I'm going to go, I was hoping to get a different color. Yeah, I can get a different color now. Let's go with a nice, blue. We want this, right, beyond 550. We want out here. And if you follow what we did in the last problem when we were working with the empirical rule, we took the 5% and we split it in half. Can we do that here? Can we say that, well, there's at most 25% outside over here and over here? Can we say half of it falls on this side and half of it falls on this side? And the answer in this case is no. Why not? Because we don't have the symmetry. And so on this side, what we're asked to find in this problem, we're going to say is at most 25%. If I ask you what percentage of the book costs are less than 250, we would say at most 25%. If I ask you in between 250 and 550, we've already seen the answer there is at least 75%. And sometimes people have trouble with this. They're saying, wait a second, that doesn't work. We have 75, we have 25, we have 25. And my response to that is we don't. We have at least 75, we have at most 25, and we have at most 25. But when you add up this guy, and that guy, when you add up the real numbers, what's it have to sum to? Well, it has to sum to 100%. The best we can do here is say that when you look at 550 above, you got at most 25%. You can see that when we're using the empirical rule, when we ask above 550, we're getting a much more accurate, I didn't want to do that, sorry about that. We're getting a much more accurate answer. We're getting a 2.5% or approximate 2.5%. Why is it more accurate? Because we have more information. We have the empirical rule. We know the shape. And so that's how we're going to solve the second part of the problem. Again, there's a Chebyshev part. There is an empirical rule part. All right, so let's go on and look at the third part. What proportion of textbook costs are between $325 and $625? Well, to solve this question, we're going to start with the empirical rule. And again, let me go get a pen. This one is the most difficult, and I think I want to do it the red again. If I can get there. Here we go. This is the most difficult of the problems. All right, should have a red pen now. All right, so we have 400 right here. So this is 325. And so we want to use that. One standard deviation below the mean, and then we saw this was 550. Here's 625, so I'm using different values this time. I'm going 3 standard deviations above the mean to 1 standard deviation below the mean. What percentage of my data fall in here? And now this, I'm going to do it a little different. When I shade, when I get to the mean, I'm going to shade in different directions, because this is how we're going to have to solve this problem. And so this problem, we're going to use the empirical rule to solve. And what we're going to find is that we need to use the empirical rule because we need the symmetry. I won't ask you this question if I'm asking you to work with Chebyshev, because you won't be able to solve it. And you'll see that as we go through. All right, now, how do we solve it? Well, I've shaded in different directions. I'm going to recommend you do that when you're working with the empirical rule, because our rule, our empirical rule itself, remember, when it gives us the numbers, it gives us between plus and minus 1, plus and minus 2, plus and minus 3 standard deviations. We know, and these are not approximate numbers, we know the 68% here. We know the 95. I'm just going to write the number. We know the 100 here. That's what the empirical rule tells us. Approximately 68, 95, 100%, 1, 2, 3 standard deviations. All right, now let's just look at this part right here. Let's look at between 325 and 400. Let's take a look at that piece. What do we know about that? Well, it's part of the 68, but we can do better than that. Not only is it part of the 68% that the empirical rule tells us about, what else? It's not just part, it's exactly, or in this case, I guess we have to say approximately, half. So this part on this side, between 325 and 400, which is the mean right here, which I'll draw in like that, that's going to be approximately half of 68, which is 34%. And if I go and look at this other side over here, come on down to the 3 standard deviations and then go up here at 400, what's this region going to be? Well, we know approximately, ooh, not a bad approximately sign there, 100% fall within 3 standard deviations of the mean, but that falls from here to over here. Well, if that's 100% or approximately 100%, what's this guy? Between 400 and 625 is approximately half of that, or 50%. I have to use the symmetry. It's the only way to get the answer for this problem. That's why I can't ask you this problem with Chebyshev. I got to take half the 68 and half the 100. Now, what do I do with the half the 68? What do I do with this 34 and this half of the 100? What do I do with the 34 and the 50? We add them together. And so the answer for this problem between 325 and 625 is going to be approximately 84%. And that's our answer. That's the correct answer. Could be a little higher, could be a little lower, but we're going to say approximately 84%. Can't even answer this question with Chebyshev, and yet we get a pretty accurate estimate when we work with the empirical rule. Now, what you should be able to do, I chose this value. I chose 325, which was 1 standard deviation below. I chose 625, which was 3 standard deviations above. If you're seeing this and if you're understanding it, you should be able to also come here to the 250, to the 175, to the 475, to the 550. You should be able to take any two of these numbers and be able to ask yourself the question, what's the proportion that falls between those two numbers, and be able to come up with the answer. For instance, you should be able to tell me what falls between 175 and 250. You should be able to answer that. And you're going to be using the numbers 68, 95, and 100, and our symmetry, and either adding or subtracting them together depending on what I ask for or what you ask for. Now, more difficult idea. We're not looking at a pie chart anymore. Some of you guys are clicking, you're saying, hey, that makes sense, I got that, that's good. And others are saying, bring back the pie charts. And we have a lot of pie chart questions, but we also have some of these. Remember, this is the more difficult type material. And if you don't see it right now, that's okay. And as I step back and look at all the red marks that I have on the sheet right now on this page, there's a whole lot of stuff going on right there. And so let's step away from it, do some of the homework problems, and when we get together again, I will do another example of Chebyshev and the empirical rule to help you through it. So that's what I have for you in the descriptive statistics. If you have any questions, you can always go to the discussion board and post a question there, or you can send an email. So long.